Hello everyone, my name is Zoltan Balazs and this is the Machine Learning Security Evasion Competition 2020. I'm the head of Vulnerability Research Lab at CUJO AI and I'm known for my zombie browser toolkit, the hardware firewall bypass tool, malware analysis sandbox tester tool. I played with some crappy IoT devices, for example my exploit code ended up running on 600,000 IP cameras, and I invented the idea of encrypted exploit delivery. I'm the co-organizer of the Hacker Surely Meetup, program committee member of the Hacktivity Conference, and volunteer at IoT Village. And this is a joint project together with Dr. Hiram, who is an architect at Azure Trustworthy Machine Learning at Microsoft. And he's also co-founder and co-chair at Chemlis, and his background is from signal processing and machine learning, and information security was just added later. One of his relevant researches is the reinforcement learning-based antivirus evasion, and he's also the co-creator of the Ember 2017 and 2018 datasets. Machine learning is used, for example, in image classification. For example, it can be a very common task for machine learning models to classify images, whether they can see a school bus, for example, on an image. And there was an interesting research in the past where researchers had to modify an existing image in a way that they add some data to it, and the image for any human observer will remain the same, as you can see on the right side. But if you basically just add the overlay, which you can see in the middle, to the image on the left, some machine learning classifiers will detect that what they can see on the right is an ostrich and not a school bus. Machine learning is also used in malware detection, and there was an amazing machine learning malware detection bypass 2 years ago. You just basically had to extract the strings from a known game and just append this to the end of known malware. And this is how you were able to bypass some machine learning models. And 5 years ago, I was already playing with machine learning based malware detection bypass. And 5 years ago, you were even able to do this with UPX. And if you are interested in the details of this game string attack, you can find the details on this link. 2 years ago, we started this competition, and the purpose was to advance the field of offensive and defensive machine learning based malware detection. Step 1 was to download 50 working malware samples for all the contestants, and they also had to download the free machine learning models with their weights. So this was basically a white box attack. Then they had to modify the malware samples to evade detection by all models, and if they were lucky, then they could win this NVIDIA Titan RTX GPU. And the whole competition was announced at DEF CON 17 AI Village. Also 2 years ago, the following machine learning models were used: the Ember Light GBM model, the malconf model, and the non-NAC malconf model. I'm not really good with machine learning, but this is a basic description of how the malconf model works. So if you are really interested into the details, then you can look into these. But what were the outcomes of this competition? At all, 70 people registered, and 11 contestants were able to bypass at least one machine learning model. And the winner was William, and here you can see his write-up. You can also find other interesting write-ups, for example, one from Jakub and one from Fabrizio. But what kind of approaches were used to win this competition? Some people try to pack the samples with a packer, and this is nice, but unfortunately if a malware sample is already packed, chances are that it will not work. And this is partially a competition-specific issue as you were dealing with malware binaries, and if you create your own samples, then you don't have to repack anything. And on this following slide, you can find all the different packers which are on the internet, commercial ones, free ones, some used in malware samples. Another interesting approach is to add new sections to the executable, and you can use the Leaf project, for example, to do that. And it's even better if these sections are from known benign files, for example, resources from Microsoft files. This works most of the time, but it can break malware. And some malware packers, they have self-checks, and adding new sections can break this. And also what's funny, that just by adding a new section to a sample, you might even bypass some antivirus detections. I believe this is mostly for performance reasons. For example, some AVs might use shortcuts for signature checks, and they only do some of the checks if the number of sections of a sample is exactly a number. Another approach was used to append extra data to the end of the executable. This is called an overlay technique. And actually this was the winner strategy. It's dumb, plain and simple, but it works. And this is basically a white box attack, and if you have all the resources to brute force, for example, machine learning models, this can be a very easy solution, which works. This overlay technique by default will not bypass static signature antivirus checks, unless there's a rule in the antivirus that some of the checks only trigger if the file size is less than, for example, some megabytes. And basically what happens here is just you create the overlay, append this to the end of the file, and you can win. Here you can find a visual representation of a malware image, and here you can find the same malware image, but just I added some repeating patterns to the end of it as an overlay. So here we can basically easily visually compare that the first sample was used in the second one. Key takeaways we had from this competition. The Markov and non-neg Markov models were too academic, not very effective in practice. Leaf project is awesome, and I recommend to use it whenever you are dealing with malware binaries. And malware is tricky. For example, some samples do not reproduce the same indicators of compromise over time. This can be because, for example, server is down, or there are some time checks in it, or some things are just random. Also, dealing with packed or protected samples are hard. I also checked some of the samples with SSDeep. SSDeep is basically a fuzzy hash, and the way it works is that there are two samples from the same malware family. Then by generating the fuzzy hashes, you can easily calculate that these two malware samples are close together. And what was interesting that as some people were adding repeating patterns, either as sections in the middle of the file or as an overlay to the end, this resulted repeating patterns in the SSD hash. And that's really interesting because you cannot see this in benign file or malware samples, and I'm pretty sure this can be only used for ML model bypass. Next year, in 2020, we have renamed this competition to mlsec.io. We added a new Defender challenge, where you had to create your own machine learning model and submit it to the competition in a Docker-based format. The attacker challenge was also changed because now it was not a white box attack against the machine learning models, but a black box attack against the submitted defenses. So source code was only provided for the Ember model. Last year and this year, the sponsors and partners were Microsoft, CUJO AI, VMware, and MRGF with us. And you were able to win Azure credits for your machine learning research plans. In the defensive track, 2 submissions passed the minimum requirements. This means these submissions were able to detect malware samples with a minimum amount of false positives. These were the malware families used last year competition. These were just basically representative samples from that year. If you want to participate in this year competition, which I will also talk later, then basically what you have to do is to register at the mlsec.io website, review the terms of services, download 50 malware samples, do your magic, verify that the malware is still functional. You can also use our API to submit the samples and upload your zip files. And last year, because there were free machine learning models, you could get up to 3 points for each samples. And also to win, your solution had to be published. Some tips and tricks you can use to win the competition is to add or remove signature, change section names or properties, modify imports or exports, create a TLS callback, change PA header, fix or change the checksum, add, modify or remove version information. You can add some new entry point that redirects the code flow or change some code or data which doesn't break the functionality. Droppers and self-retracting error hides are not allowed to use, and also multiple registrations is against the rules. We also have a Slack channel which you can still join and have some interesting conversation regarding offensive machine learning. Now, this is how our website looked like, and we were using Python and Flask admin for the user interface. Cloudflare, Nginx, and Gunicorn were used for scalability and performance reasons. We also had some Python backend scripts scheduled by Chrome, and VMware Sandbox was used in the background to get and extract all the indicators of compromise of all the submitted samples. We also have an API. So for example, if you only want to submit your model and analyze with all the ML models, then you can use this API request. If you only want to submit it to one specific model, because you already know how to bypass the others, then use this endpoint. You can get the results here. You can also upload your final zip file for a whole analysis and to be checked in the sandbox. Query the status of your submission, or also query all samples you have submitted or just a specific sample. Now, let me show you a quick demo. So you go to our website, check the terms and services. You can also see a lot of additional background information from the Defender and Attacker challenge on the following site, which will be updated for this year's competition. Now you can register or log in with either Microsoft, GitHub, or Google. Then download the malware samples. And if you check the malware samples, you can see that we have 50 samples in it with a sequential order in their names, which you have to keep because we have to be able to check which files you have modified. Now when you are ready to upload your files, you can upload them here. And as you can see, I have kept the same file names. You can also add some custom label for your upload, so you can keep track of what is what. And after some minutes, all your samples are analyzed and you can see whether it was bypassing any machine learning models. In the beginning, because this is still in process, you don't see the results, but you can be sure that you uploaded still a valid file. So as you can see, it is now in processing ML status. Meanwhile, I recommend you to check out your user and change your nickname from the randomly generated one to a better nickname. And you can also see the total API queries you have already done. This will be counted into the final score. So please try and do not hammer or DDoS or services. These were the end results of last year challenge, and as you can see with the nickname Need for Speed, they have reached the best score, 150. And there were 3 other competitors who were able to submit, and they have reached at least a score. Now, as you can see, the machine learning process has been finished, and these test samples, they were not able to bypass detection. And I think that's all I wanted to share with you. So the winners of 2020, the attacker track by the nickname Need for Speed was Fabrizio and Marcus. Congratulations for that. You can download their paper from the following URL. And the Defender track winners were Erwin, Lucas, Michael, Daniela, and Konrad. They also have a white paper. And the second place for the Defender track also goes for Fabrizio and Marcus. And the attacker track second place was won by Wunderwuzzi. I highly recommend you to check out his blog. He has also a lot of interesting research from red teaming there. The attacker winner used XOR-based scripter, base64 obfuscation, and a lot of dead imports to the import table. And the defender winner was using the PE-Berus solution, which were using different machine learning models, semantic gap detectors, and stateful defense. In total, 60 people registered for the competition. 2 people submitted a valid Docker image with a working machine learning-based malware detection inside, as I already told you. And 5 people were able to bypass at least a single machine learning model. And the machine learning engines checked samples at least 5,000 times in total. If you are interested in how these samples worked out in real life, I recommend you to check out our blog page. And it was interesting to see that these bypasses were also useful not just in our competition, but if you upload the samples to VirusTotal, they can also bypass some of these detections. And next, the floor is for Hiram, who will show you the tool which were used in the 2020 competition, which can help attackers to bypass the defenses.
My name is Hiram Anderson, and I'm delighted to present virtually. I'm going to be presenting the Machine Learning Evasion code walkthrough. This tool was included in the sample solution to the attacker challenge in the Machine Learning Security Evasion competition. You can download and play with this code by visiting mlsec.io and navigating to the attacker challenge GitHub repo. Our example solution was designed with the following things in mind. Number 1, the models to be attacked were submitted by contestants in the Defender challenge that concluded previously. 2 models from the previous round qualified to be included in the attacker challenge. In addition, we have hosted our own model to be attacked that is based on the Ember dataset. The models to be attacked report hard labels for submissions provided to them. That is, they do not provide a score between 0 and 1, but just a 0 for benign and 1 for malicious. Finally, we considered the leaderboard criteria while designing our solution. The first criterion considers the number of model evasions. With 3 models and 50 malware samples, the maximum score is 150 points. A tiebreaker would be decided by the efficiency in which the models were evaded. So we count the number of model queries. Thus, contestants are incentivized not only to be evasive, but also to do it efficiently. Contestants were able to choose any strategy that they like. To demonstrate one strategy, we released this example code on our competition's GitHub site. The code uses discrete optimization over functionality preserving file modifications using a package called HyperOpt, which ironically is often used for tuning machine learning models. You can learn more about the details from the code and documentation on the website. However, the broader strategy may be of general interest. It consists of employing an algorithm in part A to get the bulk of the malware to be evasive while remaining functional, followed by any additional manual steps in part B to fix any few remaining samples. We use the example code in our strategy in part A, in which we break our algorithmic attack into 2 phases: an offline attack against a known defender model for which we have code and weights, and an online attack. The hope is that many of the samples that were discovered in the offline attack will cross-evade the hosted online models without having used any additional queries against the API. You may visit mlsec.io to download this code. However, please be warned that when you run this demo code, you will write functional malware to disk. So please do so only using a Linux VM. To begin, we initialize the attack by analyzing a collection of benign files. The init subcommand extracts elements of the benign files that will be injected later into the malware. To launch our offline attack, we first run a local copy of the Ember model in the top window. Then in the bottom window, we'll use the run subcommand of our attack script, passing in malware samples that were downloaded by contestants. The tool will write successful evasion attempts to pass1/success and failed attempts to pass1/failure. Also included in each directory are history files that would allow us to resume our optimization of failed attempts. In a second pass, we begin with only the pass1 failures and iterate on the optimization, again storing successes and failures to a folder of our choice. Having now collected candidates that evade the Ember model, we use those candidates as seeds for an online attack, which now counts against our API query usage. The online attack is enabled with a simple -- online flag. After several iterations, we can now gather the successfully evasive variants and create a zip file to be uploaded to the website. Since there is a chance that the file modifications have broken some of the files, contestants have been encouraged to run the samples in a Windows 10 sandbox to validate functionality before uploading to the competition website. As a final note, since the hosted models may learn from the queries issued by contestants, there is a possibility that an evasive variant discovered by a contestant at the beginning of the competition may no longer be evasive to a model by the end of the competition, because the model has changed its state.
And new this year that we will start the Defender Challenge on June 15 and the Attacker Challenge on August 6th. And we have a new, easy, beginner-friendly phishing track, which I highly recommend for all of you to check out. And hopefully this new track will attract more participants for this competition. So that's all, folks. That's all I wanted to share with you. Thank you for your attention. If you have any questions, you can reach out on any of the first platforms. Thank you.